You're asked to find the inverse of this function. So first thing I'm going to do is switch this to y and then replace x and y with each other. So I really have x equals 3 times y to the power of 3 minus 4. Now I'm just solving for y, so I add 4 to both sides. And then I'm going to be dividing by 3 on both sides. And so I have x plus 4 over 3 equals y cubed. Now I'm taking the cube root of both sides to get that y by itself. So my inverse should be the cube root of x plus 4 over 3. Now we're going to verify that by plugging it back in. So I'm going to take what I just had here and plug it into x. So I got 3 times the cube root of x plus 4 over 3, x plus 4 over 3 to the power of 3 minus 4. Order of operations, I'm going to start with the exponent here, and when I have a cube root and then I cube it, those two things end up canceling out. So I have 3 times x plus 4 over 3 minus 4. Then I do multiplication, and then this 3 cancels out from here. I have x plus 4 minus 4, which when I simplify, I get just x, which means that I have verified. Last one, how would you need to restrict the domain to be able to find the inverse? Well, in cube root functions, or cubic functions, when we take the inverse, because when we look at the graph here, if we were to take the inverse, the graph then becomes this kind of like S shape here. This is still a function. This green one, or the inverse, is still a function, which means we do not have to restrict the domain when we are taking the inverse of a cube root function. With quadratics, we do, because remember we had a parabola, and then when we turned it on its side, we had it not pass the vertical line test. So we have to be careful on that. With cubic functions, with the inverse, you don't have to restrict the domain.